image quality metrics. A number of parameters depict the quality of image. First one includes the interference ratio that is calculated using the following formula. C by I is equal to E by I naught into RB by BC. C by I is the carrier to interference ratio. E by I naught is the energy per bit to the interference power. RB by BC is the rate per bit to the channel bandwidth. Second is the bandwidth. Spread spectrum permits all the frequencies and time slots to share the same channel BC, and hence it is said to have a higher bandwidth. The third parameter is the processing gain that greatly affects the following application. Coming to the CDMA gain concept, we can see from figure 12 that the spectrum code spreads the signal, which has a bandwidth of Bs, over a bandwidth of Bc. The gain, which is defined by 10 log Tc by Ts, is high, where Tc is the channel period and Ts is the spread code period. Signal to noise ratio. This is another important parameter that contributes to the quality of image received. The graph to the right shows a plot of 4 different gold codes over 4 different channels. It gives the distribution of error rate over the number of users as well as the energy. For limited users, this ratio seems to be low, considering the concept that with limited number of users, the number of available PN sequence codes are less. Thus, the number of users directly affects the C by I ratio, contributing to different bit error rate values. PSNR can be calculated by a simple formula as shown, where N indicates the number of pixels in an image, I0 indicates the actual image transmitted, and IR indicates the image reconstructed at the receiver end. Root mean square value. A parameter called root mean square value gives the mean error between the transmitted and received image. The root mean square parameter enables characterization of the quality of received image. This plot shows that for a higher signal to noise ratio, which in turn implies better signal quality, the root mean square error is less, while it reduces with degraded signal levels. This can similarly be calculated using the following formula. Conclusion. This paper thus reflects upon the challenges of present-day radio links. The need for transmission of large data at higher rates led to the analysis of CDMA-based spread spectrum multiple access scheme. The CDMA scheme proved to be efficient in terms of a number of parameters, namely interference ratio, processing gain, bandwidth, and reliability. It is verified that the CDMA access scheme is unique and reliable over all channels and does not cause any significant degradation over the wireless transmission channel. This experiment thus helps us evaluate many factors of CDMA multiple access when it comes to wireless transmission of data over such channel. The evaluation is defined based on metrics associated with image transmission and is proved to be very effective and efficient. Future work. There can be further coding over the given CDMA link, including but not limited to wavelet coding. Wavelet coding revolves around complex orthogonal wavelets. Such an algorithm can be an extension to the existing CDMA link, thereby enhancing the present image quality. This concept can be extended to video transmission to help find out the various metrics involved and extend any further development. Wideband CDMA can further be harnessed and tested for quality image transmission. Acknowledgement. First and foremost, I would like to thank Dr. Depang Wu for providing me the opportunity to take up this project and study. I appreciate his guidance and spontaneous availability. Also, I would like to thank all instructors, including the teaching assistant as well as research assistant student who helped us with our doubts. Last but not the least, I would like to thank University of Florida for this informative coursework. Thank you.